Assalamualaikum and hi everyone. In this lesson, you are going to learn on how to write the Lewis dot symbol for an atom, and then state the octet rule and describe how atoms obtain the octet configuration. And lastly, you will learn on how to describe the formation of the following bonds by using Lewis dot symbol. In this case, you are going to learn on how to draw the formation of the ionic or electrovalent bond, covalent bond, and lastly the dative bond or coordinate bond. Basically, we have three main types of chemical bonding. They are ionic bonding, covalent bonding, and metallic bonding. So, ionic bonding refers to the electrostatic force of attraction between the cation, that is positive ion, and an ion, the negative ion. So, this is the example of the ionic bonding between this cation and this anion. The electrostatic force of attraction between these two opposite ions will form ionic bonding, because ionic bonding refers to the electrostatic force of attraction between two opposite ions. The second bonding is covalent bonding, that is formed by sharing of electrons between atoms to achieve stable octet configuration, and this is the example of the covalent bonding. You can see between hydrogen and oxygen here, both of these atoms are sharing their valence electrons. And the last one will be metallic bonding, and metallic bonding refers to the electrostatic force of attraction between positively metal cation and sea of delocalized electrons. And you can see the formation of the metallic bonding by this image. So here we have the metal cation of sodium and its valence electron. So the electrostatic force of attraction between these two, that forming metallic bonding. Since we are talking about chemical bonding, so you might ask yourself why atoms need to do chemical bonding. Kenapa atom perlu buat chemical bonding? So the answer is to achieve octet stability. So atoms need to do chemical bonding, whether it is in terms of ionic bonding, covalent bonding, or even metallic bonding, due to this main purpose, iaitu untuk mencapai kestabilan octet. Atoms need to combine in order to achieve a more stable electronic configuration that is isoelectronic with noble gas. So how many valence electron of noble gas? They have 8 electrons. So atom will do chemical bonding sama ada by sharing of electrons ataupun giving or accepting electrons, supaya electronic configuration of atoms yang terbaru tersebut akan mempunyai electronic configuration sama seperti noble gas, iaitu dengan mempunyai sebanyak 8 elektron in their new valence configuration. So that is the main purpose of having chemical bonding. It is to achieve octet stability. In order to form chemical bonding, only valence electrons participate in the formation of the chemical bonding. So as you can see from the examples of electronic configurations here, for example for the sodium, so here we have inner electrons or core electrons of the sodium, and 3s1 will be the valence electron of the sodium. So hanya this valence electron sahaja yang akan terlibat di dalam chemical bonding. Okay, and the same thing goes to the other elements here. Only valence electron that will participate in the chemical bonding. So to keep on track and to know how many valence electrons untuk setiap elemen, okay, dan juga untuk nak mengenal pasti adakah elemen ini setelah mereka forming chemical bonding, adakah mereka telah mencapai octet stability ataupun belum, maka scientists propose this Lewis diagram ataupun Lewis dot symbol. So what information we can have in this Lewis diagram or Lewis dot symbol? So firstly, you may know the number of the valence electrons. Okay, daripada Lewis dot symbol, you boleh tulis, okay, you boleh identify the number of valence electrons. Like sodium has 1 valence electron, so it will be represented by 1 dot over here. Okay, so 1 valence electron represent by one dot or one cross. You can use this symbol dot ataupun this symbol cross. So one dot or one cross here represent satu electron. So for the oxygen, since it has 6 valence electrons, so we are going to have 6 dots or 6 cross over here. So by using Lewis diagram, or the other name is electron-dot symbol here, we might have information tentang the number of valence electron untuk setiap element. And after this element undergoes chemical bonding, whether it is ionic or covalent bonding, we can observe later on adakah jumlah dot on this specific element telah pun mencapai octet stability ataupun tidak. So by having this electron dot symbol, kita boleh dapat info tentang dua perkara. Yang pertama adalah valence electron untuk neutral element, dan yang kedua, you can also identify sama ada this atom or element, selepas mereka membentuk chemical bonding, adakah mereka sudah pun mencapai octet stability ataupun tidak, by calculating the number of dots in each of the element. So in this Lewis diagram or electron dot symbol, kita akan tulis symbol of setiap element. So like this, ini symbol untuk element, dan juga the number of their valence electrons by using dot ataupun cross. So element in the same group will have similar outer electron configuration ataupun similar valence electron, and they will have similar dot symbol. For example, all elements in group 1 will has similar valence configuration, and they will have sebanyak satu dot to represent that they are element in group 1. These are the examples of Lewis diagram or Lewis dot symbol for elements in their respective group. So for elements in group 2, all of them will have 2 dots, showing that they have 2 valence electrons. So all dots here represent the group number except for the helium. So for example, for group 15, they will have as much as 5 dots or 5 cross. And for group 18, for example, they will have as much as 8 electrons in their valence configuration. So the purpose of having chemical bonding adalah supaya all these atoms akan mempunyai electronic configuration yang isoelectronic to these noble gases, sama ada by sharing of electrons ataupun losing or accepting electrons. According to octet rule, atoms of other elements than helium and group 18 will achieve stability by losing, accepting or sharing electrons. Selain daripada helium yang mempunyai 2 valence elektron, dan juga group 18 yang sudah pun mempunyai sebanyak 8 valence elektron, so atom selain dua kumpulan ini akan mencapai stability dengan cara buang elektron, kehilangan elektron, terima elektron ataupun sharing their electrons. So after the atoms dah pun mengalami this activity, sama ada losing, accepting or sharing the electrons, the new electron configuration later is said to have maximum stability apabila the new configuration is isoelectronic with noble gas. So apabila atoms ini telah mengalami proses buang elektron, terima elektron ataupun sharing elektron, the new electronic configuration sepatutnya akan mempunyai configuration yang sama seperti noble gas, iaitu isoelectronic with noble gas, mempunyai electronic configuration sama seperti noble gas. So by the time those atoms apabila mempunyai new configuration sama seperti noble gas, maka mereka sudah pun dikatakan mempunyai maximum stability. And this stability can be in the form of duplet stability dan juga octet stability. So duplet stability adalah having 2 electrons in the valence configuration, and for octet adalah dengan cara mempunyai 8 elektron in the new valence configuration. In part C, we are going to describe the formations of the following chemical bonds by using Lewis dot symbol. So we will see on how this ionic bonding, covalent bonding and dative covalent bonding will be formed, and how does atom will achieve their stable octet configurations in these respective bondings. The first bond we are going to discuss is ionic or electrovalent bond. Ionic bond refers to the electrostatic force of attraction between oppositely charged ions. So this ionic bond involves metal atom and non-metal atom. So after this metal atom lose its valence electron, it will form cation. So let's take sodium as the example. So after sodium losing its one valence electron, it will form an A+ ion. And later on, this electron released by the sodium just now will be received or accepted by the non-metal atom. So by receiving that one electron, non-metal atom will become an ion. So let's take chlorine as the example. So after chlorine receive that one electron here from the sodium, chlorine will form Cl- ion. So when these two ions in a short distance or close distance with each other, maka akan wujudlah daya tarikan elektrostatik yang kita panggil sebagai ionic bonding. So ionic bond ini bukan hanya terbentuk apabila kita ada metal cation sahaja. Okay, so any form of the cation, okay, when they are attracted to negative form of the anion, ini yang akan mewujudkan ionic bonding. In the formations of ionic bond in sodium chloride NaCl, sodium is a metal, so sodium will lose its one valence electron to form an A+ ion. So as you can see in this new electronic configurations of the cation, so this configuration is said to be isoelectronic to noble gas configuration because an A+ ion has already achieved noble gas configuration with 8 electrons in the new valence shell. So formations of Na+ does obey the octet rule. Meanwhile, for the chlorine, so chlorine is the non-metal element with 7 electronic configurations. By receiving or accepting one electron from the sodium just now, so the Cl atom will form Cl- ion. In the new configurations of the Cl- ion, it has 8 electrons in the new valence shell, which is isoelectronic with the noble gas configuration. So the new electronic configurations here is also said to obey the octet rule. So this is the purpose of the formations of the ionic bonding. Okay, for NaCl, kenapa kita buat ionic bonding ni? Kerana each of this element ingin mencapai octet stability, okay, dengan cara losing electron ataupun terima electron. Ionic bonding involves the formations of the cation of the metal and an ion of the non-metal. Jadi, pembentukan of this cation dan juga anion akan mempunyai beberapa jenis stabilities. So, the stabilities of this cation and anion can be classified as noble gas configuration, stability of noble gas configuration, stability of pseudo-noble gas configuration, stability of half-fill orbital, and stability of inert pair effect. So now you are going to see the different types of stabilities of the cation and anion that form in the ionic bonding. Let's see the first stability, that is stability of noble gas configuration. Group 1 and 2 elements tend to donate valence electron to form cation with noble gas configuration. For example, we have sodium with one valence electron here. So after losing this one electron, So what will happen adalah we will get Na+. So here sodium akan buang satu elektron, okay, untuk menjadi Na+. So now you can see in this new electronic configuration for ion Na+, okay, it has as much as 8 electrons in the outer shell. So this configuration is said to be isoelectronic with neon. Okay, so now this ion has achieved noble gas configuration, okay, which follow octet rule. Calcium, okay, in group 2 has 2 valence electrons. So you can see from the electronic configuration as well, ada 2 valence electron di sini. So apa yang akan terjadi adalah calcium akan donate its 2 electrons. Dia akan remove its 2 electrons to become calcium 2+. So by removing this electron, maka we will get the new electronic configuration for calcium 2+. And you can see that at the end of the configuration here, which refers to the valence configuration, Ca2+, calcium 2+ has as much as 8 electrons. So by having 8 electrons in the outer shell or valence shell, these ions is said to have stability of noble gas configuration. Meanwhile, non-metal elements from group 15, 16 and 17 tend to accept electron to form an ion that having noble gas configuration. For example, we have oxygen, group 16 element. So here from the electronic configuration, you can see that oxygen has 6 valence electrons in its outer shell. So, daripada 6, nak mencapai stable octet configuration that is 8. Okay, so what oxygen should do? Definitely, it will accept 2 more electrons. So, accepting these 2 electrons, oxygen atom will become O2-. And as you can see in this new electronic configuration for O2-, the valence shell here already have 8 electrons. So this new configuration, okay, sudah pun mencapai stability of noble gas configuration. Okay, that follows octet rule. So that is the purpose of the anion accepting the electron, okay, in ionic bonding. The other example will be fluorine. So fluorine is group 17 elements. And in the outer shell over here, or valence shell, we do have as much as 7 electrons. So, to achieve noble gas stability, maka fluorine will accept another 1 electron. So, by accepting this 1 electron, fluorine atom will become F-. So, in F-, its electronic configuration will has 8 electrons in its valence shell. So, ini adalah valence shell yang baru untuk fluorine and ion. So these 2 electronic configurations in O2- and F- is said to be isoelectronic with neon. Second type is stability of pseudo-noble gas configuration. So this kind of stability involved in elements with block D in its electronic configuration. So elemen yang mempunyai block D di dalam full electronic configurationnya ada kemungkinan untuk mempunyai stability pseudo-noble gas configuration selepas dia buang electrons, okay, losing its electrons. So after forming the ions, this ion will has similar electronic configuration with noble gases, tetapi it is not exactly the same as noble gas configuration. Okay, so bila not exactly the same, itulah yang kita panggil sebagai pseudo. Pseudo means false ataupun palsu. Bermaksud that ion yang telah kehilangan elektron itu akan membentuk ion yang mempunyai electronic configuration yang quite similar to noble gas, tapi not exactly the same to the noble gases. Okay, let's see this one example. We have gallium. So gallium is group 13 elements, You can see from the valence configuration here, gallium has 3 valence electrons. So, since it is a metal, so gallium tend to remove its electron. Okay, remove berapa banyak? Dia akan remove sebanyak 3 electron. So, by doing that, this will be the new electronic configuration for gallium 3+. And as you can see in this new configuration, kita tidak mempunyai 8 elektron di petala yang paling luar. We don't have 8 electrons in the outer shell or valence shell. Kita ada penambahan 3d10 di sini. Okay, so kalau 8 elektron ini sahaja bermaksud it is isoelectronic with noble gases. Tapi dengan adanya 3d10, so this electronic configuration is not exactly the same as in noble gas. Okay, dia adalah similar, lebih kurang sama. Okay, seperti noble gas configuration. Okay, so yang mana yang lebih kurang sama tu? Okay, disebabkan oleh apa? Disebabkan oleh ada presence of 3d10 di sini. So this cation is said to be stable because the highest principal quantum number has a completely filled orbital, 18 electrons. Okay, so this kind of ion is said to have stability of pseudo-noble gas configuration, okay, which is stable configuration juga, kerana mempunyai completely filled orbital pada setiap orbital 3s, 3p and 3d. So jumlah ni semua adalah sebanyak 18 electrons. Since these electronic configuration are not exactly the same to any of the noble gases, so they are termed pseudo-noble gas configurations. Pseudo means false ataupun palsu. So you boleh tengok pada periodic table, there will be no noble gases yang mempunyai jumlah elektron seperti mana di dalam gallium plus ini. Okay, disebabkan oleh ada kewujudan of this 3d10. Okay, so that's why kita panggil dia sebagai stability pseudo-noble gas configuration. So the valence electron configuration of cation, okay, yang jatuh di bawah stability pseudo-noble gas configuration ini adalah the one yang having this valence configuration, NS2 NP6 ND10 or NS2 NP6 ND10 and F14. So here we have another example. So we have zinc with this electronic configuration. So zinc is a D block elements, okay, and it is a transition metal. So if you can recall what you have learned in previous chapter, the valence configuration will be 3d10 4s2. So ini adalah apa? Ini adalah valence configuration, okay, yang mana 10 dan juga 2 itu merujuk kepada valence electron. Okay, so for transition metals, they can remove electron by stages, berperingkat. So for the case of zinc here, zinc can form zinc 2+ by removing these 2 electrons only. So bila buang 2 electron ini, maka the electronic configuration will become 3s2, 3p6, 3d10. So with the presence of this completely filled orbital 3d, 3p complete and 3s2 juga completely filled orbital. So this kind of cation configuration is said to achieve pseudo-noble gas configuration. Okay, this configuration telah pun mencapai stability of pseudo-noble gas configuration. The third stability of ion is stability of half-filled orbital. So in this case, D block elements, that is transition metal, can donate or release electron to form cation that have stability of half-filled orbital. So apa maksudnya half-filled orbital itu? Maksudnya adalah this ion of this atom, okay, will have 5 single and unpaired electrons. Okay, kita labelkan sebagai D5. So for example, we have manganese atom. So manganese atom here is the transition metal, and this will be the valence shell for manganese. Okay, valence shell for manganese. So since it is transition metal, so manganese boleh buang multiple electron stage by stage. So for example, in this case, manganese would like to remove 2 electrons. So here for 3d5, this will be the configuration for 3d5, and this will be the 4s2. So in order to form the ion, manganese will release 2 electrons. So which electrons will be removed from the atom? Definitely will be the one in the outermost shell. So by doing that, by releasing that 2 electrons, maka kita akan dapat in our valence shell akan berbaki 5 electrons. So these 5 electrons will have this arrangement, 5 single and unpaired electron. So the ion that has this kind of arrangement in the outermost shell is said to achieve stability of half-field orbital. The other example is ferrum 26. So for ferrum 26, we can see that this will be the valence shell of ferrum. So ferrum can lose electrons also to become cation. Okay, persoalannya, how many electrons should be removed by ferrum in order to achieve this stability of half-field orbital? So from here, in order for this ferrum to achieve stability of half-field orbital in its ion, maka it has to remove 2 electrons from 4s and 1 electron here from the pairing in 3D. So by doing that, we will get ferrum 3+, menunjukkan kita dah buang 3 electron, and in our ionic configuration, we will form 3d5. Okay, so this 3d5 refers to the stability of half-field orbital. And the last stability of ion is stability of inert pair effect. So elements in group 13 and 14 in period 5 or 6 will form cation with this electronic configuration. So we know that for group 13, the valence configuration will has ns2 and p1, and for group 14, the valence configuration will has ns2 and p2. So in this case, for these elements of group 13 and 14 in period 5 or 6, they can form cation, tetapi this cation hanya akan remove electron daripada p orbital sahaja. Okay, so after removing electron from this p orbital, maka they will form cation yang masih mempunyai electron pada ns. Okay, so this phenomenon can happen only for group 13 and 14 in period 5 or 6 or bigger. Okay, for period lower than that, element group 13 and 14 must remove both electrons from ns and np. Okay, so exception hanya untuk group 13 dan 14 in period 5 or 6. So a few large atoms form stable cation that have a pair of electrons in valence s orbital. So hanya untuk bigger atoms in period 5 or 6, okay, ataupun bigger period yang ada tendensi untuk remove electron pada p orbital sahaja. So the 2 electrons ns2, which is here, are said to be inert as they are not involved in chemical bonding. So this is named as the inert pair effect. Kenapa inert pair effect? Sebab selalunya untuk group 13 and 14, bila kita nak form cation, kita akan remove kedua-dua electron from this orbital. Okay, kita akan buang electron daripada kedua-dua orbital. But in this case, untuk period 5 and period 6, element 13 and 14, kita hanya akan buang electron daripada p orbital sahaja. Okay, so itu yang dipanggil sebagai inert pair effect. Okay. For example, we have tin element here with these electronic configurations, and you can see that we have 5s2, 5p2 in the valence shell. Okay, menunjukkan bahawa this tin element has 4 valence electrons. Okay, and it comes from group 14. Okay, so here, this element is located in group 14 dan in period 5. So, bila mana kita jumpa sahaja group 14 period 5, so it has tendency to remove only electrons pada 5p ini. So, after removing these 2 electrons dalam 5p, so maka you will get the new ion configuration that is Sn2+. Kenapa Sn2+? Sebab kita buang 2 elektron sahaja di sini. So, buang 2 elektron, maka forming 2+. Okay, so the new configuration will be, okay, the valence shell will be 4d10 5s2. So, 5s ini tak dibuang, okay, dalam pembentukan of the bonding. Tapi dia hanya buang 5p sahaja. So, ini yang dinamakan sebagai inert pair effect. As the conclusion, in ionic bonding, non-metal tend to accept electron to form an ion, and this anion will have stability of noble gas configuration. Meanwhile, for the metal tend to donate electron to form cation, and this cation can have different types of stabilities. They can have stabilities of noble gas configuration, pseudo-noble gas configuration, half-filled orbitals, and inert pair effect. So all these are the types of stabilities of ion that is formed in ionic bonding.